Hello, and again, welcome back to another segment of Terminating Low Voltage Cables. I'm Ron with IDEAL, and welcome to my shop. Hey, this is part two of a two-part series on telephone circuits, so if you didn't get a chance to reach part one, you might go check it out. But this is part two of basic telephone circuits and some ideas of what you should know about them as you're working with them. Now, in part one, I left off with how do we actually dial out today and you actually use a phone and what it's doing. Here we're going to start with kind of how we start from the outside of the house and bring that wire into the home, okay? And when you look at how the telephone company brings wire to the side of the home, they're going to do what we call airily, off a pole, off the backyard maybe, could be front yard, and it could terminate to just a porcelain terminal up underneath an eave someplace if you got an older installation. A lot of new construction, of course, will be underground and coming out of one of these little pedestals that's sitting in somebody's backyard, or it could be front yard, and terminating to the side of the home. Now, one problem about putting wire in ground is that it is going to get moisture in it, and I can't tell you when, but that jacketing will break down over time. And if that happens, the A number can cause the static in phone lines. And if you're guessing it's moisture in the cabling, you'd be correct. And it's either in that drop to your house, or it can actually be further back into their system as well. Okay? So that's one downside about putting it in the ground, but for safety reasons, you'll find that's the case. Now, the gray little box typically we terminate to on the side of the box, or where this point comes to, is called a demarcation point. Well, it's referred to as demarc. And essentially, that's where they own it. And from there on into the home, we own it. Okay? So your gas meter is your gas demarc, your electrical meter would be your electrical demarc, and for phone circuits, it's this gray-looking box. Okay? And it has been for a lot of years now. Now, in North America, both Canada and the United States, this green box is basically split in half, okay? And in the telephone company side of the box, it's going to be marked, and you're not really allowed to get into that, but you're not going to find nothing in there really but a simple connection going from their side of the box over to the customer side of the box. And when we open up the customer side of the box, you're going to find connections that look like this, okay? There'll be red, green, or it might be red, green, and yellow, black. And you see that RJ11 jack right there? The telephone company will run a wire from their side of the box, and they'll plug into that position into the customer side, okay? Now, as I said in part one of the course, of the videos, that this is an electrical circuit and it does have some electricity involved in it. And if you're a little worried about and you're not really sure about what you're doing inside the home, you can always run outside the house, open up this half the box, and you're allowed to get into it, and disconnect your telephone service right there. Okay, and then do the work inside the home, and then come back in and hook it back up, and everything should hopefully be working for you. Okay, now this is again your demarc. So if I want to run wire from here now, in days gone by, what we would have done is we would have taken a phone wire from here, hooked it up to say the red green, ran it on into the home, and hooked up the first phone outlet. And then we would splice the cable feed the next outlet, splice the cable feed the next outlet, and do what we call daisy chaining of the cable. And then we'd run wire off this red-green terminal again, and maybe go feed the second floor of the home if that's what we wanted to do. Now, we do not really recommend daisy chaining a cable for several reasons, and one is troubleshooting because you have no idea where the splices are. Today, normally what we'd either do one of two things. We would run a single wire from this point or pair to every outlet that we want to provide phone service in the homes. And or we'd really prefer you put in a low voltage panel house that runs the phone lines, the data lines, and the video lines through the house as well. And we'd run a wire from here, from the red green, on into the low voltage panel in our home, and then again from it, we'd run individual wires to each individual outlet we might want in the house. So that's kind of the recommendation today. But again, that's your demarcation point, and it's again usually red, green, yellow, black. Although you might find some newer demarcs that are in the what we call category colors. Now, I'll explain that in a minute. Now, when you look at how you marry category colors to old colors, when you look at the connectors we put on into the cabling, these connections can be what we call plugs or a jack, okay, a wall jack. And we refer to them as RJ something, okay? Now you should be aware that there's a lot of RJs out there, and the FCC has a bunch of them. And it means registered jack is what the term actually means. And when I look at phone circuits, we typically use RJ11s in these phone circuits, and especially in residential homes. And the RJ11 can be have two pins in it for one phone line, 4 pins for 2 phone lines or 6 pins for 3. And you can see how they're wired over here. Okay. Now that plug or that jack is referred to as a 6 position 6 contact, 6 position 4 contact, and 6 position 2 contact. Now, you're going to find that all those connectors are the same size. It's just the number of pins in them. Okay, so if you have a wall plate that's a 6 position and you have a 4 position telephone cord, it would work. And if you only had one phone line and you had a 4 position telephone cord and you had a 4 position wall jack, it again would work. So again, RJ11s, okay, 2, 4, or 6 conductor. Now you see how they're wired over here, and when I look inside of a phone jack and I look at the little pins inside of here, or actually on the plug too, and I look at the number of pins, I always know line 1's in the middle set of pins. So as you see, line 1 makes up the middle set of pins. Line 2 is right on the outside of that on pins 2 and 5 in this case. And if I had a 6 conductor jack or plug, it'd be on pins 1 and 6, and so it goes one right outside the other. And you can see the tip and ring there designated as well, which I kind of talked about in part 1 of the video. Okay, now this wiring sequence you see being used here, this is how phones have been wired for a long time, and we call it U-sock wiring, and they're not trying to insult you. It's called U-sock wiring, and the little letters, if you care to know, is called Uniform Service Order Codes. Okay, and that's how phones have been wired for a long time. Okay, now, as I said a minute ago, there are times when we have to marry old color systems to new colors, and the reason this is happening is the industry is trying to get rid of this old telephone wire. This stuff was great for phone, but it's really not good for nothing else, not data for sure. And we want a cable in a wall that actually supports both. And so actually back in July of 2000, the FCC says we got to stop using this. And the only place you still can use telephone extension cord stuff like this is from the outlet in the room to the phone in the room, not behind walls. We want you to use catenary cabling. Matter of fact, the wire here is not fire rated to go behind a wall, so it's really kind of a code violation too. We want you to use at least category 3, and you're more likely probably going to be using category 5E today. But we want to use a category color. Okay. Now you'll find in old telephone colors, red green meant line 1 to me. Okay. Yellow black meant line 2, and white blue meant line 3, and brown slate meant line 4. And believe it or not, telephone wire comes up to 6,000 colored pairs in a bundle. Big stuff. In catenary wiring, you'll find that the pairs are blue, orange, green, and brown, because there's basically 4 pairs in a catenary cable. And line 1 is always blue, line 2 is always orange, and line 3 is always green, and line 4 is always brown. Now, let me ask you, is the phone smart enough to know what color wire is being hooked up with? And the answer would be no. You could mix wires here as long as you had the wiring correct, it would work. But somebody coming in behind you would expect that blue wire to be pair 1. Okay. Now, this little chart tells me if I'm working with one of these old-fashioned type of surface-mounted jacks, or I'm out there working in the D-mark and it's red, green, yellow, black, but I'm going to hook it up with catenary cables, what colors go where, and that's what this tells me. This tells me that the green screw in here is going to get hooked up with the white with the blue stripe on it, and the red screw gets hooked up with the blue wire. So that's how we do that. And you'll notice that the white conductor and all those is going to end up being the tip of the pair, and the solid looking colored of that pair is going to be the ring of the pair. Okay, and that's how we'd still use some of these old surface mounted jacks. Now, one other thing is to explain this whole patch cord thingy to you as well, because you'll run into some variations here. Telephone patch cords, as a general rule, can they'll either come straight through wired, where pin 1 on one connector is hooked to pin 1 on the other connector, and 2 is 2, and 3 and 3 is all the way through it. Or you'll find them like this one in my hand, reverse wired. And a lot of times when I look in the telephone section at the stores, and I pull one of these cords off the peg off the shelf, I'll find it's been reverse wired. And you'll find that some older phone systems needed to flip this tip and ring at the outlet in the room. So they went from the outlet in the room to the phone, they flipped this tip and ring. And you'll find most phones are really not polarity sensitive. They really don't care if it's a straight through or it's done this way. But be aware there's both out here. So here's a reversed one where you'll see that the pair 1 and 2 are in exact same positions on either side over here. And you'll see the tip and ring designated as well. And you'll see that over here that the tip on this pin 1 on this side is actually hooked to pin 4 on the other side. So if I looked at these two plugs side by side, I'll find out that they're exactly opposite of each other. Okay, so that's how those were wired. And again, you will find that, as I said earlier, you can buy some very old phones that from out of the 70s and out of the 50s if you want to. And some might actually require a reversal like this. Today, digital phones will be straight through wired. Typically, they'll work just fine. But you know, they still wire them like this because there are phones out there that still require it. And really, the phone today will work it either way. So anyway, there you go. That's a little bit about telephone basics. This is, again, the end of part 2. And again, hopefully you got a chance to watch part 1. Hey, I'm Ron with Ideal Industries, and thanks for coming, and we'll plan on seeing you the next time.